Just remember when d is positive, it's actually negative in the equation. And now we are going to sketch both graphs of the parent function and the transform function. So as I told you earlier, for parent functions, you need to memorize certain key points. Our parent function is y equals 1 over x, or f of x equals 1 over x. What are the values, key points for 1 over x? Do you remember? Do you know? You don't know? Okay, that's fine. So for 1 over x, I recommend doing -3, -2, -1, and then 1, 2, 3. So 6 points in total. I lied. You also have 0. 7 points in total. And you just plug in these values. So obviously y is going to be 1 over -3, which you can write as a decimal or you can write as a fraction, whatever is easier for you. Since you're in grade 11, you can, I guess, do decimals or fractions. Eventually, you will have to get comfortable with fractions. So I'm just going to write fractions for now. I guess I can write does not exist. So when you have an x value of 0, you can't divide by 0. So you just write does not exist, because that's not a point that exists. 1, 1/2, 1 over 3. Okay, so to go ahead and do that, copy that down. Once you have those values, your key points. What was my mapping notation? Do you remember the formula for mapping notation? Yes. Yes, x over k plus d and ay plus c. Now, what is my k value? What is my d value? Well, we did that. K is -1 over 3. And d value is +5. But as I mentioned earlier, whenever you're dividing by a fraction, I'll just show the proof again. When you're dividing by a fraction, you flip the second fraction and change the sign to multiplication. So it becomes -3 or times -3. So dividing by -1 over 3 is the same thing as multiplying by -3. So this really just simplifies to -3x. Makes our lives a lot easier when you write it this way than if you were to write it like the other way, right? And then ay plus c, what's a? Do you know what a is? And then what's c? Perfect. Once we have our mapping notation, let's plug in these values into our equation. So -3 goes into 3. Sorry, it goes into x. What's -3 times -3? 9. 9 plus 5 is 14. Perfect. And then you just keep doing that for all of them. So -2 times -3, that's +6. That's 11. That's 3, 8. 0 is going to be 5. Plug in 2. It's going to be -6, -1. Plug in 3, -9, -4. So we got our x values. What about our y values? Same thing. Plug in -1 over 3. So 2 times -1 over 3 is -2 over 3, which is -0.667. Add 4 to it, you should get 3 1/3, or 3.33333. -half, plug in a -half, times it by 2, that's -1. -1 plus 4 is +3. -1 times 2 is -2. -2 plus 4 is just 2. Now here, when you're plugging in 0, it did not exist, so this is going to be the same point here. D&E. We have when you're plugging in 1. Wait, did I miss something? Apologies. Oh, I forgot to put 1 in here, right? Yeah. Sorry, I forgot 1. So plug in 1 here. That's -3, that's 2. And then you have, I mean, you can see a pattern. It's going down by 3s. See that, right? So there you go. And let's go. So if I plug in 1 here, 1 times 2 is 2. 2 plus 4 is 6. This is 6. Plug in a half. That's going to be 5. Plug in a third. That's going to be 4.66. So we have our values now for our transformed function. Did you follow? You're good? If I went too fast, let me know. Then I'm just gonna get my chart paper here and I'm going to graph it. So we're gonna graph our parent function first. Our parent function, just so you know, has a asymptote or vertical asymptote at 0. And it was 1 over x. So if I've hid the table, so I can't really see the table right now. But I mean, you can check that 1 over 1 is going to be 1. When my x value is 2, y value is a half. When my x value is 3, it's going to be 1 over 3. So it's something like this. And here on this side, we had -1, I think. So when x value is -1, y value is -1. X value is -2. Y value is going to be -1/2. And I guess we didn't pick any points between 0 and 1. So this is where I forgot that you're supposed to use -0.5 and +0.5 as your key points to get more data. So if I plugged in -1/2, or sorry, let's do it +1/2. So 1 over 0.5 is 2. So if x value is a half and y value is 2, and then if I plug in -1/2 for x, y value is -2. So you see the trend, it's kind of going like this. Sorry, my mouse is not very good. Yes, so it never touches the y or the x-axis. There's also a horizontal asymptote here, and then like that, and then like this. So this is our parent function. So our parent function has all these values, or sorry, has these values, but also the asymptotes, I mean. So our transformed function will also have asymptotes. But where? That's the question. Well, the easiest way to tell you is your asymptotes are going to be your C and D values. That's the easiest way. So your C value and your D values will tell you your asymptote. So what's my C value? 4. So 4. So I should have a asymptote at 4. What's my D value? 5. I should have an asymptote at 5. Let's see if that makes sense with the points that we've gotten. And once again, I forgot to plug in the halves, so that's fine. We'll do that later. But the points that we do have are 14, x of, okay, 14 is off the scale, but 11 is pretty close. 11 and 3. So we have 11 and we have 3. 1, 2, 3. Roughly here. 8 and 2. 8 and 2, roughly here. 5 and does not exist. Okay, makes sense. This is where the half would have helped figure out what's going on, but that's fine. 2 and 6. 2 and 6, that's the value here. -1 and 5. X value is -1. 5. -4. -4 and 4.66. So you can see that the function is going like this. And you see, well, you can't see because we were missing a point, but you can see the function is going to go like that. So it really helps by drawing your asymptotes first. I highly recommend always drawing your asymptotes first, and then you kind of know how the curve is supposed to look like. Because you know it's 1 over x, so you know it's going to be a curve, and you know there's going to be asymptotes. So this is it. Hopefully that helps. Any questions? Yes. Yep. So this is a transform function. So you can plug in 0. 0 is a point on this graph. 0 is a point. You will get a number because that's not where the asymptote is anymore. The asymptote has been transformed to now 5. So that was the whole point. So remember, your asymptotes now in your transform functions are your c and d value. C being your horizontal asymptote, d being your vertical asymptote. So that's very important. Yeah. The last thing they ask you to do is do domain and range. For domain and range, for the parent function, it's xer, and x cannot equal 0. That's it. Because it's dividing by, it's 1 over x, right? So you can't divide by 0. So there is no range. It's just x cannot be 0. That's it. It can be any other number than 0. And similarly, y is the same thing because it has a horizontal asymptote. Y cannot be 0 as well. So y will never be 0. This is part of the parent function. For the transformed function, it's exactly the same, except we know our asymptotes have been transformed now. Remember, there are c and d values. C being the horizontal asymptote. So c has to do with y. Just remember, ay plus c, a and c affect your y coordinate and axis, you could say. K and d affect the x-axis. So x is affected by d. My d value is 5. So x cannot equal 5. That is the new asymptote, vertical asymptote. And y cannot be 4. That's how you do your domain and range. I know it's a lot. I know we went a little bit quicker. So I do have to go in a few minutes. But yeah, I think that's it. For today, we'll do a little bit more practice afterwards.